guys, today we're going to be considering the second case. As contrary to the oil and water mixture, we're going to consider the solubility of an ionic solute, like sodium chloride, in a polar solvent like water. So, in this sort of solution, our delta H1 is going to be large and positive, because the strong ionic bonds in these crystals must be overcome, right? And we know that the ionic bonds are the strongest bonds, and that this reaction, the crystals are going to have to absorb a lot of energy to be broken apart. So we can assume that our delta H1 will be relatively large and positive, of course. And our delta H2 will also be relatively large and positive, because when we think of water, the polar molecule, we have to think of the H bonds occurring. So we have to think about the fact that if I have H2O here, and I have another one here, there are going to be H bonds. If this is my hydrogen, this is my oxygen. I would draw this the other way, but there are going to be H bonds that need to be overcome by the attraction of these two molecules. Finally, our delta H3, as you would expect, would also be large, but it would be negative, because the strong interactions between the water molecules and the ions. So, here's I'm trying to, make it as, realistic as possible, but without having to draw as much. And the exothermic and the endothermic terms essentially cancel. So, an example they gave, which I'm going to, briefly illustrate over here to, rationalize the thinking, in terms of numbers, is they had sodium chloride. I'm going to sort of write it out. I just don't want, the awkward silence, plus the Cl gas. I'm just sort of trying to, what they do with these equations after they explain them, conceptually, is they're rationalizing in terms of, logic, because a lot of people here are probably used to, math and equations, but a lot of this is considered conceptual thinking. You have to think in a way you wouldn't necessarily think before, which is the mystery of AP chemistry, right? Okay, so they're showing here that the delta H1 is equal to 786 kilojoules per mole, and they're saying here that the delta H of hydration, which I'll explain in a second, is equal to the sum of H2 and H3, which is equal to negative 783 kilojoules per mole. So, the delta H of hydration, or the enthalpy of heat of hydration, is the combination of the terms delta H2 and delta H3. Delta H2 for expanding the solvent, and delta H3 for the solvent-solute interactions. The heat of hydration represents the enthalpy change associated with the dispersal of the gaseous solute in water. So, as it's sort of just existing. So, the heat of solution in sodium chloride we can assume to be delta H1 plus the delta H of hydration, which is the equivalent to delta H1 plus delta H of 2 plus delta H of 3, because this is equal to this. Okay, so in order to, going back over here to, in fact, how the endothermic and exothermic essentially cancel, think of our heat of solution. Our heat of solution is all of this summed. So 786 plus negative 783 gives us a value of positive 3, but essentially it canceled out. There's 3 joules left, right? So now I think that my delta H1, which was the splitting and the expanding, took 786 kilojoules. This positive because it's endothermic, because sodium chloride had to absorb heat to break apart into these ions. And then my delta H of hydration, we just said, is delta H2 plus delta H3. Delta H2 is the expansion of the solvent. Here we observe the water. The delta H3, we say, is the solvent-solute interaction. So we're going to include the ions and the ions here that are in the solvent after it's expanded. So the sum of delta H2 plus delta H3 is negative 783 kilojoules. And if we do the quick math calculation as we did here, we see that essentially it will cancel out, hence the combination. And also, if you're a little confused on why the solvent and the solute together in the solution are considered one step, they're summing it, because when you're accounting for, let's say, water, you have to also account for the fact that in this mixture there's gonna be ions floating around after you disassociate the bonds in the ionic compound.